Hello all. In today's session, let me learn about how to obtain the left as well as your right shift operation using only one single shift register. Along with that, how to obtain all the four types of shift operations using a universal shift register. Now, let me move to your directional shift register. Which is a shift register which can do the shift right operation as well as your shift left operation. So it can perform both shift right as well as your shift left operation by having your two serial input and two serial outputs. So now in order to have your shift right operation, we have to connect your serial data input through your AND gate, which is a number one. So you have your left operation on your shift left operation on this register, connect your serial data input through the eighth AND gate. So now in order to have these both shift operations of serial in serial out, so we need to use, in addition with this data flip-flops, a combination circuits are used which can consist the two AND gates, one OR gate, and the two AND gates outputs are connected as inputs to the OR gate. Every OR gate output must be transferred as your data inputs. Now, so here these two AND gates on your each flip-flop are being connected, one input on your control input, other input on your control input bar. So here third AND gate input is connected to control input, fourth AND gate input is connected onto your complemented control input, and fifth AND gate is connected with your control input, and sixth AND gate, one of the input is connected to the complemented control input. Same manner, seventh AND gate input is connected on control input, and eighth AND gate input is connected on your control input. Simply here, so I have given as a control input, but we will name this. It can give you the operation of both shift right as well as your shift left operation. So hence this control input, let it read as your right or left bar. So right or left bar. So only one single control input we are going to use. So if I transfer logic 1 on this control input, it can give you the right shift operation of your serial data is shifted towards the rightward direction. So when your this control input is at logical 0, if I transfer on this, so 0 bar now it become logic 1. So it accepts your data at your right end and it can shift the data towards the leftward. So like this you can have your both shift operations. For example, now if I wanted to have your right shift operation, so now one of the first AND gate is connected to control input, so it can enable the AND gates of all odd numbered AND gates. So first AND gate is enabled, third AND gate is enabled, along with fifth as well as your seventh AND gate is enabled, since right is equal to 1 and one of these, all the AND gates are connected to right. So right equal to 1, so output of this first AND gate depends on your serial data input, output of this third AND gate depends on your first flip-flop output, output of your fifth AND gate depends on your output of your second flip-flop, seventh AND gate output depends on your third flip-flop output, which are connected as your data input. So like this, so if I wanted to store a data or shift the data of 1101, so through the serial data input, by enabling your right input equal to logic 1, I will transfer the first data bit as your serial data input. So hence for the first clock pulse, so your data one input is transferred through the serial data input through a AND gate and through the OR gate as your data input. So immediately on a clock, QA will be transferred with logical 1, and these all will give you the 0 output. So immediately we will give, so because initially all the registers are restored, so with a reset state, so all will have 0, but due to this first data input which is entered through your serial input on your first clock pulse, so first flip-flop is loaded with the first data bit. Next second clock pulse, so we will transfer 0 and output of this QA, since right is 1, so third AND gate is enabled, so this one is transferred as your data input. So due to that, QB become logic 1 and now QA is having a 0 because the second bit data bit is transferred through your serial data input. So hence QA is shifted to 0 and output of your previous output of your first flip-flop is applied as your QB DB, and then your QB now shifted from 0 to 1, QC is shifted to 0, and QD is shifted to 0 from your previous flip-flops. Next, third bit for at your third clock pulse, the third bit will be transferred through the serial data input. So hence QA is shifted to logic 1, and now QB is shifted to logic 0 because previous data output of your first flip-flop is 0, that is entered through the third AND gate and applied to the DB, hence QB is now equal to 0, where QB second flip-flop output is transferred through fifth AND gate through the data input of DC. Hence here you obtain a logical 1 as your input. So next here we obtain a logical 0. Next at your fourth clock pulse, the last bit is entered into the first flip-flop, which is your 1 is entered onto the first flip-flop. This one, the output of your first flip-flop 1 is shifted to the data flip-flop. Next output of your second flip-flop is shifted to your through your seventh and get to the input, so which is equal to 0, and your output of your third flip-flop is shifted through the AND gate, seventh AND gate as your data input. So hence 1 is transferred on this last flip-flop as your output terminal. So in serial out shift right register, we will take out the serial output from your extreme right end flip-flop. So from this QD we were going to collect your output. So serially, right, in the same manner. So when I wanted to shift the data in leftward direction, so I need to enter the data, so which is on your extreme right end flip-flop. So hence, so we are going to transfer. Now the control input is loaded with 0. So now when control input is 0, 0 bar become logic 1. So this first line will be activated, which is your left bar is activated. When left bar is activated, so the even number of AND gates all are active and the odd number AND gates are all disabled. So here the even number AND gates are 2, 4, 6, 8 all are enabled. At the same time, it can disable the odd numbered AND gates which are 1, 3, 5, 7. So hence, so we can provide a shift left operation by inputting the data on your extreme right hand flip-flop through your 8th AND gate. So that serial data input is transferred through the 8th AND gate and transferred through the OR gate as 8th AND gate output is connected as your input to the OR gate. OR gate output is transferred with your data input. Hence, you would obtain your QD, and that QD is transferred as the input to the 6th AND gate. So the second clock pulse output of this is shifted to the data input of your second flip-flop. So QC is again connected through the 4th AND gate to the DP, and QB is connected as through your second AND gate. So like this, data is shifted one bit towards the leftward direction. So by this 4 flip-flops with additional logical gates which are combination circuit with one control input, we can have your both shift operations in your serial in serial out, which is shift right operation as well as your shift left operation. The same manner, so you can also have the 4 types of shift operation which can be done using your register called universal shift register. And in order to construct that universal shift register, we are going to use 4 flip-flops along with 4 multiplexers. So multiplexers are data selectors. So each order is 4 by 1. So 4 number of 4 multiplexer we used here, where each are having 4 inputs along with 2 selection inputs. Now let me connect all the selection inputs together as S1 and S0 here. So next here, so now based on your selection inputs S1 and S0, so now let me see that operation of your universal register using your selection inputs. So if S1 and S0 are 0, 0, so then the previous state has to be continued as your next state. So that state is defined as your no change state. when S1 and S0 are 0, 1, so we should have your shift right operation. So the data must be shifted from left to right. 1 0 shift left operation is achieved through this universal shift register, and 1 1 it has to accept the data parallelly and it has to deliver the output parallelly from the universal shift register. So parallel, all the four types of shifting we have done using only one register, that is known as your universal shift register. So we have been connected the clear of your all the flip-flops commonly, as well as the clock pulse which are negative edge triggered, so which I am going to use. A common clock pulse is connected, so these are known to be the synchronous. So at a time all the flip-flops are synchronized, so with a common clock signal, and then it will give you the changes in your state will be done on your common clock pulse. So every flip-flop will be responded for a single clock pulse right here. Now, so 0 0, so S1 and S0 is 0 0. So hence we have been connected this 0 input to the previous states of the same flip-flop. So this 4 by multiplexer is belongs to the first flip-flop. So the second one is belongs to the second flip-flop. Third one is belongs to the third flip-flop, and fourth one is belongs to the fourth flip-flop. So if it is 0 0, so first input of your every multiplexer is selected. So I don't wanted to change my next state, so hence the previous has to be continued as your next state. So hence we connected QA as your input of your first input of your every multiplexer. So of your every flip-flop present next states are being connected as your first data input on your multiplexer. If S1 and S0 is 0 0, so QA is connected on your first multiplexer, QB is connected on second multiplexer 0th input, QC is connected on your 0th input of your third multiplexer, QD is connected on your 0 input of your fourth multiplexer. So if S1 and S0 are 0 0, every multiplexer will transfer the 0 input. Now that 0 input is nothing but your previous state. So and that previous state is entered as your data input. So hence if S1 and S0 are 0 0, the first data input is transferred through your output, and that output is transferred to the every flip-flop data input. So 0 is connected with QA for the first one, and here second multiplexer 0th input is connected with QB, third multiplexer is QC, and fourth multiplexer is QD is connected. So previous states are continued as your next states. The same manner if it is 0 1, so S1 is 0, S0 is 1. So here I need to have your shift right operation. So serial data input for shift right is connected on your first 4 by 1 multiplexer. Let I label this as first one, second one, and third one, as well as your fourth one. So the input data must be entered into the extreme left hand flip-flop. The output must be collected from your extreme right hand flip-flop on serial shift right register. So we need to enter the serial data input. So hence we connected on your second data input of your multiplexer. If it is 0 1, that second data input is transferred as the data input. So let I connect the logical one on this. So 1 is shifted onto this data flip-flop 1. So if it is 0 1, so every multiplexer second input is transferred through the output and applied. So now that second input is nothing but, so here previous outputs QA is also connected as your second data input, QB is connected as your third second input, and QC is connected as your second input of your fourth multiplexer. So if it is 0 1, all the second data input terminals are transferred through your multiplexer output terminal, and that are entered as your data input. So hence the data is shifted, so in the right word 1 bit on a single clock pulse. So through the serial output data terminal you can have your shift right operation is performed. Upon having your 7 clock pulse, all the data bits will be taken out from your last flip-flop which is on QD. Same manner. So in order to obtain your shift left operation. So the third data input of every multiplexer has been connected for your right hand flip flop. The third data input is connected for serial data input for left shift, and now this QD is connected. So the right hand flip flop output has been connected as third input. QC is connected as your third input, and QB is also connected as your third input. If S1 and S0 are 1, 0, so then all the third inputs are transferred as your output to the multiplexer. Since those third inputs are coming from your right hand flip flops, so now the data is shifted towards the leftward direction. So here the first flip flop would obtain the data input from your flip flop 2. Flip flop 2 obtain the data input from your flip flop 3, and flip flop 3 obtain the data input from your flip flop 4. So like this, data being shifted from your right flip flop to the left flip flop, one bit on a single clock, and they are exit from your extreme left hand flip flop output, which is your QA, from your QA output or your first flip flop output. So like this we can have your shift left operation on your universal shift register. So if S1 and S0 both are equal to logical 1, so then the last input, which is the third one here, so which are transferred with the parallel data inputs, so which are from DA, DB, DVC, DT, are transferred as your output terminal. So when these S1 and S0 are 1 1, from each multiplexer the third data input is transferred through your output terminals of your multiplexer. So first multiplexer will give you the output of DA, second multiplexer will give you the output of DB, and parallel input DB, and parallel input DC, as well as your parallel input DD, and those are entered as a data input. Immediately on your clock pulse you obtain your UA is equal to parallel outputs, which is equal to the parallel inputs DA, DB along with DC and DD. So like this, so we can have your parallel in and parallel out shift register. So using this universal shift register, by having only 4 D flip-flops along with 4 multiplexers using 2 control inputs, so we can have here all the 4 types of shift operations, which are serial in, serial out, parallel in, serial out, parallel in, parallel out, along with serial in, parallel out shifting operations. Can be these all operations are derived from one single shift register, which is known as your universal shift register. So with this, so we finished our shift register. In the next session we are going to